Part 2 starts from here. Let's see the second question. First step is to read the question properly, and you can see two images. The living quarters of a shuttle has a volume of 20,000 liters at 500 milliliter of mercury. So in the first image you can see a shuttle here, and we are considering the living quarter, which has a volume of 20,000 liters, and the air inside it is at a pressure of 500 milliliter of mercury. Now this shuttle docks with the space lab. The volume of the space lab is given as 230,000 liters, and there is no air inside the space lab. The question arises, what does the air pressure in both become when the hatch is open between the two? So you can see here that the air is only present inside the shuttle. Inside the space lab we have no air, so the pressure inside the shuttle will be more, and inside the space lab we practically have no pressure because there is no air, it's all vacuum. So as we know that we have a tendency of the fluids which include liquids, and in this case we are taking the air into consideration, that is a gas, because we are talking about the Boyle's law. The air will flow from the higher pressure to the lower pressure unless and until the pressure between the two containers becomes same. So in this case the air will flow from the shuttle to the space lab unless the pressure inside the shuttle as well as the space lab becomes same. So the pressure inside the shuttle will decrease, right? And inside the space lab the pressure will increase. After some time the pressure inside the shuttle and the space lab will be same. First of all, we need to analyze what is given and what needs to be found, which is the second step. So let's see. I have taken the pressure 1 as well as the volume 1 is that of a shuttle. Why? Because the air will be flowing from the shuttle to the space lab. So the pressure 1 and the volume 1 is of the shuttle. Volume of the space lab is given as 230,000 liter, and we need to find the pressure corresponding to it. Here in this question there is a catch that we will not consider the volume, only the space lab, because the air will be moving from the shuttle to the space lab, and the air will be present inside the shuttle as well as the space lab. So to find the new pressure that will become, when the hatch is open, we will not only consider the volume of the space lab, we will add the volume. We will add the volume of the shuttle as well as the volume of this space lab. So the volume 2 will be equals to 230,000 plus 200,000. This will come out to be 250,000 liters. So we will be considering this volume to find the pressure when the hatch is open. The third step is to check for the units. Here the volume 1 is also in liters and the volume 2 is also in liters, so both the units are same, so we need not to do any kind of conversion here. We will only substitute the value in Boyle's law equation. It's given in the question that the temperature is constant, so the Boyle's law can be applied and we can just substitute the value in the Boyle's law equation, which is pressure 1 into volume 1 equals to pressure 2 into volume 2. I'm substituting the values, that is 500 mmHg into 20,000 liters, and we need to find the pressure 2, and the volume will be 250,000 liters. So the pressure 2 will be 500 mmHg into 20,000 liters divided by 250,000 liters. The unit of the volume will get nullified, and here I'm cancelling these zeros, and 25 2. So the pressure 2 will be 40 milliliter of mercury. So that means this is the pressure which becomes inside the shuttle as well as the space lab when the hatch is open. When the volume was less, we were considering the volume of the shuttle, so the pressure was more. And when the volume was increased, which was the volume of the shuttle as well as the space lab, the pressure got decreased. So the pressure is inversely proportional to volume, which is Boyle's law. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.